everyone. Welcome to episode number 604 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. My guest this week is John Heinlein from Sonatus. John and I are talking all about software-defined vehicles. We explore the historical development of automotive software, the role that over-the-air updates play in SDVs, how Sonatus is encouraging innovation in this space, and where John thinks software-defined vehicles are headed in the future. Keeping with our automotive theme this week, I also check out new research from Purdue University that contends that ChatGPT could help autonomous vehicles interpret passenger commands and drive accordingly. But first, please welcome John once again to Fish Fry. Hi, John. Thank you so much for joining me.
Nice to be here.
So, John, the last time you were here on Fish Fry was 12 years ago when you were with ARM. Now you're the chief marketing officer at Sonatus. So tell me about Sonatus and what you're working on.
Yeah, that's right. I was one of your early guests. I'm looking for my coffee mug for being like a long-time guest. I spent 14 years at ARM in many different roles. It was a phenomenal experience. I finished my career at ARM in their automotive business, working with automotive partnerships across North America. So it was a natural segue to move into Sonatus. Sonatus is a Silicon Valley-based automotive software supplier. We provide a lot of really interesting foundational software, and we're in production with major OEMs like Hyundai, Kia, and Genesis. Matter of fact, we just crossed a major milestone the other day. Our customers have shipped over 2 million vehicles into production using Sonatus technology. And the landscape here and what Sonatus is doing is really about the shift to software-defined vehicles, or SDV, I may say for short. SDVs offer really compelling benefits to the industry, to the automotive industry, and to their suppliers. One of them is SDVs allow OEMs to reduce cost by streamlining vehicle architectures, helping them shift to things like modern networking technologies like automotive Ethernet, consolidating hardware units together, and much more. And this can unlock a platform for modern software development, including things like cloud-native design, rapid innovation, rapid prototyping. And it also enables vehicles to become upgradable, allowing improvements in time and in quality, as well as the potential for new revenue streams. And this last point about upgradability is an important topic I hope we can touch on later.
Excellent. Now, John, what is the benefit for OEMs to work with you guys versus building their own software-defined vehicle capabilities?
Yeah, I think it's important to look at the landscape of how vehicles have been developed, particularly when it comes to software. Historically, OEMs have been less involved in vehicle software, and often they've relegated that into their subsystems, often developed by tier one suppliers, where they say to a tier one supplier, here's an RFQ for you to make a thing that manages the windows. Tier one supplier brings back a box. A lot of times it's a black box, and it makes the windows go up and down, and there's some software inside. But a lot of times that software is deeply embedded in those subsystems. There's now been an industry shift towards OEMs being much more involved, taking much more control of software, up to and including potentially doing everything themselves. Now, the OEMs are doing the right thing by caring about software, and you're seeing now that across the landscape, across the world. But I would say that doing everything themselves might not be the best approach. What we're looking and we advocate for is a balanced approach that we think is much more cost-effective, much more economical, where OEMs build software on top of foundational technologies and then add their own differentiation on top. It's a bit like the analogy I've used many times is when you have a laptop that has a USB port. You didn't buy the laptop because it has a USB port. You just sort of expect that to work. But there's tons of things that your maker has to do on top of that to add additional value, whether it's software capabilities and so on. So the way we've done that is Sonatus leaders come from automotive companies for sure, as well as many of our founders have a background in the data center world and the data center networking world. And we think there are huge benefits to leveraging data center expertise into vehicles. Some people say that vehicles are smartphones on wheels, and there's some helpful mental model to that. But the reality is they're more like data centers on wheels, given the many mission-critical systems interlocking technologies, complicated networking, and much more. So what we do and our product line does is meant to respond directly for this need for key foundational technologies. The Sonatus vehicle platform provides 5 critical interlocking products that solve various infrastructure challenges every SDV will need. For example, our Sonatus Foundation product provides key foundations for things like vehicle networking infrastructure, managing data, managing applications. Sonatus Collector provides highly configurable data collection and management to do things like asking fine-grained questions to address vehicle problems, understand vehicle usage, improve performance, and so on. Sonatus Automator provides the ability for OEMs to do sort of if this, then that type of processing in a vehicle where they say, in this situation, when these complicated set of things happen, do this thing, whether that's call an API call, whether it's to notify the driver or take out some other action. Sonatus Guard focuses on cybersecurity and preventing things like intrusion, especially around vehicle networks. And finally, Sonatus Updater, which I hope we can talk about a little bit later, talks about the importance of OTA updates. But all of these products provide critical foundations on which OEMs can innovate, deliver cost savings, deliver value creation into their vehicle platforms. But we're not replacing the OEM. We're giving them, I like to say, a higher place for them to stand to then deliver their own differentiating capabilities on top.
So let's talk about over-the-air updates. Now, that is definitely a critical component for software-defined vehicles. How do OTAs need to change to address the needs of SDVs? And what's your guys' approach to that?
Well, let's start with the landscape of OTA for a little bit. And everyone knows how software updates work on their mobile phones. You get app updates and operating system updates all the time. And they're delivered wirelessly or over the air, or that is to say, OTA for short. Now, vehicles use OTA today, but in a much more limited way. Only some vehicles allow OTA updates, so it's growing. Right now, for example, it's famous that Tesla is doing frequent updates as often as maybe every few weeks, but they're really at the leading edge. The fact is, every modern vehicle contains software and millions of lines of code in leading edge vehicles. But that software today is often buried inside some of those compute units I talked about earlier. A high-end vehicle could have as many as 100 of these compute units called ECUs, electronic control units, that have software buried inside. So if you look at the landscape today, industry analysts, SBD Automotive, we work with them closely, they say that most updates today, preponderance target the IVI or infotainment system, and they focus on delivering new features. Another common source of OTA is updates to the advanced driver assistance systems or ADAS. And then finally, after that, some comfort features, things like some new capabilities for maybe HVAC or something like that. But other systems are updated less frequently. Today, the vast majority of these updates provide new features to the driver, and then some other updates provide bug fixes as the second most common approach. But as we shift to SDVs, software is going to become much more fundamental. But importantly, SDVs also re-architect the software architecture of the vehicle to be much more upgradable, fundamentally more upgradable, more based on modern software development practices like cloud-native design and CI/CD, where software is designed and prototyped in the cloud and then delivered to the vehicle. SDVs also put software in more places throughout the vehicle, and I would say in more places that are upgradable, especially. We think OTA updates for SDVs are going to become more frequent, more pervasive, and I would say more increasingly important, both to the OEM and also potentially to the drivers who are going to get a new and incremental value from those OTAs. We think they're going to target more systems throughout the vehicle because we think there are many untapped potentials in the vehicle. So think about, for example, as we shift to EVs, you have propulsion systems and battery systems, and the science for how to manage batteries is evolving over time. We know there's going to be a need to add incremental efficiency, use these systems in a smart way, and OTAs can be a great way to add new improvements as that knowledge grows. To manage these increasingly frequent and increasingly more complicated OTAs, you're going to need an OTA management solution designed for the needs of the SDV era. Now, this year we launched Sonatus Updater, the 5th of our 5 products I mentioned a minute ago, and we've had incredible interest from OEMs for this solution. And Updater brings some powerful innovations that are going to be critical to enabling this success. The first is something called dry run prototyping. Imagine you're about to deploy an update to thousands of vehicles, maybe tens of thousands of vehicles. Well, you want to make sure before you press the proverbial big red button that you know how much it's going to cost, you're doing it the right way, and it succeeds the first time, especially if that's going to cost you tens or hundreds of thousands of dollars if it works, let alone the cost of if it doesn't work. So that's really important opportunity for OEMs to get that right the first time. Another important change in SDV is you're seeing more and more different kinds of software. Historically, when we talked about vehicle software, we would have thought about firmware, something embedded in the flash of some ECU. But now you're seeing more things like containers, machine learning models, different configurations, network provisioning, and more. And we handle the requirements of that diverse set of different kinds of software and different kinds of updates. Another important thing is OTA sizes can be massive, and probably they're going to only grow over time. Updater contains state-of-the-art compression technology that dynamically adapts the best algorithm for each data type, because if you don't know anything about data, not every data type compresses the same way. And so if you use a one-size-fits-all approach, you're going to get a less than great result. We're also working in other ways to save cost. Instead of sending the entire image, we can send just the changed portion, which can help significantly save transmission costs, whether that's over Wi-Fi, and definitely in those cases where you're going to need to send an update over LTE, which is even more expensive. Now, finally, despite all of our efforts, sometimes an update might fail. Today, it's very difficult generally to diagnose what went wrong. Updater includes detailed traceability to help OEM engineers quickly isolate the issue and resolve it and make sure that they can move on from there. So we believe Updater is an integral enabler of the shift to software-defined vehicles and the fact that OTAs are going to be becoming much more integral to SDVs in the years ahead.
So, John, what's next for software-defined vehicles? And what should we expect from Sonatus in the coming months?
Well, it's exciting times. We're doing innovations in so many different ways. When I look at the customers we're meeting with, every one of the customers is excited to the shift to SDV. I mean, there's work to be done. It's not to say that they can snap their fingers and all of a sudden their vehicles become SDVs. They need to do that, but they're really appreciating the benefits it can bring. Sonatus just rolled out a presence into commercial vehicles. We're looking to expand our presence because of the same value proposition that we're doing today with passenger vehicles can also apply into commercial vehicles. That's very exciting. And we have some new secret things that I'm not ready to talk to you about today that we're going to be demonstrating at CES 2025. So if you come to CES, we'd definitely love to visit you. We're going to be in the West Hall with a massive booth, and we look forward to showing off the kinds of things we're doing to accelerate the shift to software-defined vehicles.
That's exciting. All right, John, it's time for your off-the-cuff question. So if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
I would say that I've become really obsessed with really good pizza. And in fact, I do a lot of cooking. And my grandfather on my dad's side, my great grandfather rather, was from Naples, which is many people think is the birthplace of pizza. So I've become an aficionado of learning to cook traditional Napolitano pizza. And I've got a pizza oven in the back, and I can make the pizza from scratch, from flour, and out the other end comes really traditional pizza in 90 seconds. So it's pretty impressive.
I love that. Sounds wonderful. Well, John, I think that's all I have time for today. Thank you so much for joining me.
You're welcome. Thank you so much for having me.
Can ChatGPT improve our autonomous vehicles? Well, new research out of Purdue University seems to think so. So get this. A new study from Purdue presented at the 27th IEEE International Conference on Intelligent Transportation Systems contends that AVs can use large language models to interpret commands from passengers and then drive accordingly. Ziran Wang, an assistant professor at Purdue's Lyle School of Civil and Construction Engineering, who led this study, explains it like this. The conventional systems in our vehicles have a user interface design where you have to press buttons to convey what you want, or in an audio recognition system that requires you to be very explicit when you speak so that your vehicle can understand you. But the power of large language models is that they can more naturally understand all kinds of things you say. I don't think there are any other existing systems that can do that. Okay, so this is how the study went. And no, they didn't use these large language models to actually drive the car. They were used instead to assist the AV's driving ability with its existing features. So, before any experimentation began, this team from Purdue trained ChatGPT with a variety of different commands and prompts that were both direct, like please drive faster, and indirect, like I feel a bit motion sick now. Over time, ChatGPT learned how to respond to these commands, and this team also required it to consider traffic rules, weather, road conditions, and other information that was detected by the vehicle's sensors, like light detection, cameras, etc. Now, in this first experimental vehicle, these large language models were accessible over the cloud with a level 4 autonomy as defined by SAE International. Now, when the speech recognition system in the vehicle detected a command or prompt from the passenger, the large language models in the cloud reasoned the command with the parameters the researchers defined. And then from there, these models would generate instructions for the vehicle's drive-by-wire system, and then would drive according to those prompts. In some of the experiments, this team from Purdue also did something a little different. In these cases, they also installed a memory module in the system that stored data from those language models that included the passenger's historical preferences and would learn how to factor those preferences into a response to a command. So, in this study, passengers used commands already learned by the language models and other prompts that were new as well. And you know what they found? Based on survey data from these passengers, they were more comfortable with the decisions made by the AV compared to previously recorded information from passengers riding in a level 4 AV with no assistance from large language models. They also tested other metrics on what people would consider on average to be a safe and comfortable ride, like how quickly the vehicle accelerates and decelerates, and how much time the vehicle allows for reaction to avoid a rear-end collision. And what they found was that the AV in this study outperformed all of the baseline values while using the large language models to drive. And this even included when it was responding to commands that it hadn't learned yet. So, I hear you loud and clear, my fish frying audience. What if it doesn't hear me quite right? Yeah, well, that concern is valid. Large language models do have the ability to hallucinate, meaning they misinterpret something they learned and then respond in the wrong way. This study was conducted with a fail-safe mechanism that allowed participants to safely ride when the large language models misunderstood commands. But this is still an issue that needs to be worked out before we can get even close to implementing these large language models into AVs. But for now, this team at Purdue is going to keep on working on furthering the parameters of this study, including seeing if it would be possible for large language models of each AV to talk to each other, and even the addition of large vision models to help AVs drive in the extreme winter weather common throughout the Midwest. So, is ChatGPT for your next autonomous vehicle ride coming anytime soon? Nope, but I am intrigued by the possible uses of it in the future. So, if you want even more information about this study, or to read the associated research paper called Autonomous Vehicles Could Understand Their Passengers Better with ChatGPT, or if you want more information about Sonatus, or to listen to some other super cool automotive podcasts featuring John Heinlein, I've included a slew of links below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into X, you can monitor our tweets at EEJournalTFM. And of course, if you want to follow my personal account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, I completely dig it. You can follow us or me on LinkedIn as well. And we are now on Blue Sky Social and Mastodon too. And folks, we have a YouTube channel, youtube.com/EEJournal. It is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our new animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of October 18th, 2024, I'm Amelia Dalton, and you've been fried.